So naming ethers is kind of weird because it's one of the few where actually the functional class is used a lot more than the substitutive class for naming, and that's generally because we don't work with very complicated ethers. I mean, we're just being honest with ourselves. We don't work with very complicated ethers. They're more used as solvents than anything else because of this amphoteric property. They're both polar and nonpolar, can work with a lot of things. So the substitutive class in this part is going to treat the ether as if it's composed of two components, an alkoxy, which is basically an alcohol missing a hydrogen bound to an alkyl group that has a terminal carbocation. And this is how we name it. We're going to basically say it is an alkoxy bound to an alkyl group. The functional class is what's a lot more commonly used. And the functional class says that we're going to basically name the two carbon chains and create an ether. Now, when would you use one or the other? Well, the substitutive is actually useful if you have substitutive groups on the different chains. That said, we typically don't see those a lot. There aren't a lot of functionalized ethers, at least in my experience, that get used. So the functional class is what's used far more commonly. So let's talk about that first. For the functional class, what you're going to do is you're going to name the carbon chains on opposite sides of the ether groups. Now, you're going to do this in alphabetical order. So we have an ethyl group and a propyl group, and we're going to use the YL to designate that they are alkyl. And so this is ethyl, propyl, ether. So we have an ethyl group, a propyl group, and the ether sitting between the two. Now, this is also where you're going to see a lot of the common names show up, so like tert-butyl, isopropyl, sec-butyl, because it's just a lot easier than trying to do the substitutive class for naming these. What if you want to do the substitutive class? Well, it's a little bit more complicated. What we actually want to do is put the alkoxy on the shortest line. So here, there's a reason I drew it this way. This is the shortest alkoxy group. So we've got our ethoxy here, designating that this is an ethoxide group. And then we have 1, 2, 3 ethoxy propane. Now, we have our two components here. We have our ethoxy group, and we would name it as we would try to name any ethoxy group. So if there's functionalities on it, we would say like 1-bromo, 2-bromine ethoxy. Propane is going to be the same way. We're going to put any branches that are on it in front of it. But this is more or less how this is going to work. Now, again, typically for my course, I'm going to keep it to short, simple ethers because, again, we don't typically work with really complicated ethers. They're usually the solvent more than anything else. But regardless, here are your two names of way of doing it. Function class, which is seen a lot more because usually ethers are kept simple. And then we have the substitutive class, be a lot more versatile. That said, we typically don't exploit this versatility.